For number 6, you want to compare these two numbers, right? So again, we're going to be using either greater than, less than, or equal to. Now, keep in mind that with negative values, the larger the number, the absolute value of the number, the smaller value it actually has. So for example, -3 is actually greater than -8 because -3 is closer to 0 than -8 is, which means it's closer to the positive numbers, which means it's closer to having a positive value. So make sure you use the appropriate comparison symbol when comparing -12 and -15, keeping in mind that since they're both negative, the quote-unquote smaller one is actually the one that has the greater value here because it's closer to 0. For number 7, we want to put these in order from least to greatest. So we want to find the one that has the smallest value, which is the furthest from 0 on the left. In this instance, that would be -7. Keep in mind that 0 is going to be kind of like your midpoint. So all the negative numbers should be to the left of 0, and all the positive numbers should be to the right of 0. And as the numbers, positive numbers, they grow the way they normally grow. The other numbers, for negative, just make sure that you keep in mind that the closer this is 0, the smaller absolute value it's going to have. For 8, we are going to show this on the number line. It's a simple subtraction problem. You could show it on the number line if you want to. You don't have to. Mainly, this would just serve as practice. So we start at 5, and then we move 4 spaces to the left because we're subtracting. So that's 4, 3, 2, 1. So we move 1, 2, 3, 1, 2, 3, and then 4, which ends up with our value there. All right, for number 9, it's actually kind of complicated. We want the first 4 terms. So what that means is we're going to do this 4 times. We're going to have 3n, 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 and 3n. And each time, we're just going to replace it with the term that we're looking for. So in this instance, we're going to replace 3, substitute the n with the 1 for the first term. Evaluate, that's going to give you the first number of the sequence. In a similar fashion, you're going to substitute n with 2 for the second term, and evaluate to find the second term. And that's how you're going to finish out the rest of these. It's just replacing the n each time with whatever number term you have arrived at, and then evaluating. For number 10, we're being asked to solve for find the value of the variable. First thing you want to do is find the simplified version of this, which is 2 times 3 is 6, 6 times 5 is 30. So once you've evaluated the coefficients, the next thing to do is to identify the operation, since we have a variable involved, which is multiplication, and then identify the inverse operation of that, which is division, and then we're going to go through and divide both sides by the number that's being multiplied. For number 11, a minus 1,367 equals 2,500. Since we have a variable, we want to solve for it, so we're going to use our inverse operation, which is addition. Keep in mind that we're going to add the same value to both sides. In this instance, the number that's being subtracted, which is 1,367. Doing so will allow us to simplify and solve for the a value. For number 12, we have b plus 5 plus 17 equals 50. So before we can actually use our inverse operations, we have to simplify everything. So 5 plus 17 is the first thing we need to take care of, which is going to be 22. I don't know about you, but I'm feeling 22. Get used to that, kids. You can ask the 7th graders last year about it. Well, the 7th graders this year that were 6th graders last year. Anyway, since we're adding 22, we want to use the inverse of addition, which is subtraction. And then from here, you just subtract the same value from both sides to find the value of b. Here for 13, we have $25 minus k equals $18.70. So obviously we started with $25. We spent some amount of it. Now we only have $18.70 left. Since the subtrahend is a variable, we use our quote-unquote trick here, which is just a matter of swapping these. So now we have $25.00, and we're going to subtract $18.70. And the difference is going to be our solution. which in this case is going to be the amount that we spent with K. 14, 6,400 plus D equals 10,000. So I'm going to use the commutative property to change the order here, only on the left. So D plus 6,400 equals 10,000. And then from there, all you have left to do is to solve for D, which involves using our inverse operations. And since we're adding, our inverse is subtracting, we're going to subtract the same amount for both sides, which is 6,400. And then make sure that you simplify for the solution for D. 15, we have 144 divided by F equals 8. So normally we would use our inverse operations to solve for the variable, which is multiplication. However, the variable here is in the denominator. Being that that's the case, we use the same way to solve this that we did with subtraction when the subtrahend is the variable, which means we are just going to do a little switcheroo. So 144 divided by 8 is equivalent to F. And now to find the solution for the value for F, you're just going to divide 144 and 8. For 16, we are being asked to write this in expanded notation. So before we can write an expanded notation, we have to write it in expanded form, which is 700,000 and then plus 50,000. And after we have done that, we're going to have two sets of parentheses with factors inside of them. So remember that the first thing we want to write down is the number that since it's multiplication, the order doesn't really matter inside the parentheses. Obviously outside, like we can't flip these two, right? But inside the parentheses, the order doesn't matter. So in class, I did it one way, which was the place value times the number. But for this, I'm going to do it a different way. We're going to take the place value times, or the number in front times the place value, which in this case is 100,000. So all you have left to do for 50,000 is to write the number that's in front first, multiplied by the place value. And that'll give you your expanded notation of 750,000. For 17, addition problem, big numbers, not an issue because we know how to add. And really, we're just going to move straight down. 8 plus 5 is 13, carry the 1. 2 plus 1 is 3, 3 plus 7 is 10. And we continue carrying over anytime our sum is larger than 9, or larger than 10, sorry. And from there, you would just continue until you have a simplified answer, or sum. For 18, this is a subtraction problem. And really, all there is left to do here is regroup when necessary. So here it's obviously necessary because 4 is not bigger than 7. So that becomes a 0. That becomes a 14, which allows us to make this 7. And then we just carry over or regroup as necessary. Doing this allows us to properly subtract everything that we have here. So make sure that you regroup as is necessary, and then you have all your computations correct. 19 is asking us to just find the sum of 45, 362, 7, and 4,319. Some of you will not need to do what I'm about to do, but some of you might need help. I like to use terminal zeros to keep my place values intact, to make sure that my ones place is lined up, and my tens are lined up with my tens, my hundreds with hundreds, thousands with thousands. So that's what I'm going to do. I'm going to put these terminal zeros. I'm going to erase this 19 because I don't want anybody to get confused. I'm going to replace it with terminal zeros. And then from here, we just add straight down. That's 9, that's 18, that's 23. And then you just regroup or carry over as necessary to find your sum. Finally, for 20, it's another addition problem, but this time we have decimals. You'll notice that I lined up my ones place, 4, 4, and 6. So now I'm again going to do what I did in the previous problem, which is to use terminal zeros to represent any empty spaces. And the whole point of doing this again is to make sure that everything is lined up the way it should be. You don't necessarily need to use terminal zeros, but I like to use them just to make sure that all my tenths are lined up with tenths, ones with Tenths with tenths, hundreds with hundreds, ones with ones, tens, hundreds. Just like in Hercules, we want to make sure that our planets are lined up and that you put your decimal place where it needs to go. And then from here, you just complete your computation and find the sum. This has been your homework help for today. Now that we're done with that, the movie theaters are opening up. Harkins, anyway, is with limited seating, for to allow for social distancing. But what is one movie that you would like to watch in theaters? Now, it could be a movie that's already been out, so that you've already seen it in theaters, you just like to go again, or it could be a movie that hasn't come out yet, and you're just really excited to watch in theaters. If there was a movie that I could watch in theaters again, I saw Lawrence of Arabia in theaters, which some of you guys might not, some of you guys and gals might not really know what that is, but it's an incredibly long movie. But it was a great experience. So I'd probably go with like an old-timey movie that had like the 70mm print. So that's something that I would probably like to watch in theaters. So yeah, think of a movie, Pacific Rim in IMAX. I'd do that again. That was a fun movie to watch. So anyway, a movie you'd like to watch in theaters. That is your extra credit. Bonus points if you pick a movie that I've already watched in theaters or want to watch in theaters for the future people. All right, so that's it for today. You guys have a good day, and we'll see you tomorrow.